Okay, so picking up from where we left off in the last video segment, we have our instruments turned on. We have the digital multimeter here. There's one other piece of equipment that we're going to use I didn't show you, and that's a breadboard. And this breadboard, so-called, I'm told, because in the very, very old days, it was actually like a cutting board that people would hammer nails into to make connections. But this is a lot more sophisticated. Each of these little holes actually has a little metal spring inside of it, so when you push a wire in or you push a component in, it makes a connection for you, so you don't have to do any soldering. And the way these are connected is really pretty simple. Each of these 5 holes is internally connected, so that allows you to make connections, use this as a connection point. And that's true for every one of these rows in here. They're not connected across the valley. This is actually a valley. I don't know if you can see in 3D, but across this valley, it's not connected. And so this is another row of 5. So you have a bunch of places that you can make connections. Now it's interesting, on the edges, it's a little bit different. The red line indicates that this column, if you want to call that a column, see it's labeled with a plus, is all connected together. And that's intended to be used for providing power to all your circuitry that's built up on the breadboard eventually. And then the blue line indicates all these are connected, and that's for another voltage, usually ground. So it's usually whatever your power supply voltage is in ground. And these are separate over here. So you really have 4 different power supply voltages that you could supply to your circuit. A lot of times, just for convenience, what people will do is they'll put a jumper wire from the blue on one side to the blue on the other side, and that just gives you a lot of flexibility in how you wire up your circuit. But anyway, that's the nature of the breadboard, and we'll be using that to make our circuits. So our first part of the experiment that we want to do, if you look in the write-up, and again, yours probably is going to be a little bit different than this, so don't take this as the write-up, but I'm just using the one from last fall until I get a chance to update it. But this is going to use the digital multimeter in the power supply. All right, so the first step says to remove any cables that might be connected to the front here. And now I will tell you that there are a couple of important buttons. This big blue button is the on-off button. So if I press that button, the whole instrument is shut down, and that can be useful. I would highly recommend that in case you happen to notice flames shooting out of your circuit, which is highly, highly unlikely. But anyway, that's just a joke. Okay, so here's the big blue button, and the plus voltage coming out of here and the minus voltage that connects here to the black terminal are the only 2 we'll be using. If you're wondering what the green one is, it's marked G and D for ground. That's actually earth ground. If you were to actually measure where this goes, it would go through the power supply connector. In fact, I'll unplug this and show you. Okay, if you look on the back of this instrument, sorry about my hand getting in the way, but if you look on the back, you'll see that there are 3 prongs on this cable. Well, that one in the center at the top, I won't point to it because my hands are full, but in the center is earth ground. In fact, if you look at the cable itself, you can see that center connection. Well, that's earth ground, and what that means is there's actually a wire that literally runs through that cable into the wall and out of the building someplace to a stake in the ground, a copper pipe that goes into the earth. And that's why it's called earth ground. It's the ultimate reference point for all electricity that comes into this building. It's actually referenced to the utility power company that supplies our electricity. We don't have a need for that in this lab. In some equipment hookups, you want to use that, but we're not going to. I just wanted to let you know what that was. And you have that in your house or apartment or dorm wiring as well. So if you ever wondered what that is, now you know. All right, so we've got the power supply and the digital multimeter. So what are we going to do with those? Well, first thing that says to turn on the power supply and adjust the output voltage until it shows exactly 4.56. All right, so what you got to do is look at where this LED is and move it over, because we want to adjust the last decimal place. It just happened to come on it at this voltage, so I only have to adjust the hundredths position. Well, the way you do that is you push. I don't know if you can see, but I'm pushing in this knob right here. You can hear it click. And when that LED is under the last decimal place, then I can adjust that, and it'll stay like that. And the digital multimeter is supposed to measure voltage in the 20 volt range. So what we've got to do, and I'll point out this is AC because it's got a little sinusoid, and this is DC because it's got a flat line. So we want to get the pointer all the way over to here to the 20 volts. All right, if I can do that. Okay, so now the pointer is on the 20 volt line. That's great. So what we can do now is the next part of the instruction says connect the test leads to the red and black terminals of the power supply, the plus and minus. All right, so here are the test leads. Make sure that your red one is connected into this thing with all the jumbled up symbols. It says hertz, volts, ohms, and continuity. And then make sure the black one is plugged into common, or COM. Okay, we're not going to be using these other two jacks right now. All right, so we're going to take these and we're going to connect them to the power supply. Well, how should we do that? The easiest way to do it for this purpose is literally just stick in the probe, and when you do that, you will get a reading. And there you go. That says 4.55. That says 4.56. So which one is right? Well, it really doesn't matter. Those are so close. They're within 100th of a volt that we really can't complain about that. Okay? And so let's not get worried about things that are in the hundredths of a volt position, unless we happen to be doing something that was so highly precise and required so much precision that we needed to, in which case we probably wouldn't be using laboratory equipment that cost $80 and $100. We'd probably be using thousands of dollars laboratory equipment. So anyway, this is good news. We can now measure the voltage. All right. Now you're going to see in your lab write-up there are things that are in green, and those are things that you're supposed to actually write down, data you're supposed to take. Okay. So this says record, well, green and purple, I'm sorry. It says record the DMM voltage reading. I forgot that I updated the color coding. So that's what you're supposed to write down, and then you're supposed to address this in your lab report is where you're supposed to write words that says compare it to the display on the power supply. Well, this says 4.55, this says 4.56. So what you would say in your lab report is the voltage on the DMM is 1/100th of a volt less than the voltage on the power supply. According to Dr. Roppel's instructions, this seems like it's very close, and it seems like they're within experimental error. Now, what just happened on my DMM will probably happen to you. These particular meters, we didn't know it when we bought them, and I probably still would buy them because I like them, but they have this nasty feature of having an auto off setting that you can't override. And so what had just happened is my meter just shut off because it's been on for a while. You have to push this yellow button twice to get it to come back on. All right. So when you do that, it'll come back on, same reading. Now you have whatever the timeout period is left to use it. All right, so there you go. There's that first measurement. And the next part of the next step is going to require us to connect some resistors onto the breadboard and measure a circuit. So I'm going to end this segment since I'm coming up on about 10 minutes, and then I'll go to the next segment.